Hi, my name is Stu McNeil. I'm with the Carnegie Science Center at Pittsburgh, Pennsylvania. And today, you and your classmates are going to learn what it takes to build a skyscraper that can stand up to some pretty strong winds. Skyscrapers are one of our most amazing achievements. Towers like the One World Trade Center in New York City, the Willis Tower in Chicago, or the tallest tower in the world, the Burj Khalifa in Dubai, tower thousands of feet over the surface of the earth, all while standing up to the elements. One of the elements that engineers need to be especially careful about is wind. Think about it. Have you ever been out in a windstorm? Have you ever felt the building move or shake when it gets hit by a strong gust? How about the pig who built his house out of bricks? Why did his house stand up to the wolf's huffing and puffing when the house made of straw and sticks couldn't? Wind is a lateral force. That means it moves sideways. And when this sideways force strikes a building, it exerts pressure. Different parts of a building may react differently under that pressure. The big flat panes of glass that line the side of a skyscraper might move, bend, or even rattle when struck by wind. But a skinny chimney can have that wind whoosh right around it, meaning it exerts less pressure. Today, you and your classmates are going to build a skyscraper that can stand up to some of those really harsh winds. To do this, you're going to need 4 pieces of paper, 2 yards of tape cut into whatever sizes you need, and a metal washer or a small coin or other flat object that can rest on top of your tower. You'll also need an electric fan and a measuring tape. The tower you build needs to do 3 things. It must stand 14 inches off the testing surface. It has to stand on its own, can't be taped down to the testing surface, and it has to support that metal washer on top. Now, I'm sure you're excited to get building, but before you do, let's make sure we use the engineering design process. First, we think, then we build, then we test, then we do it all over again. The engineering design process is what engineers use to make sure that they always have successful projects. Now we think. Do I want to fold the paper or roll the paper? Do I want to make the Empire State Building or the Eiffel Tower? Where is the wind going to hit the building, and what is that going to do? Maybe sketch a few of these ideas out and use them for your next step. Now we build. Start taking the paper, fold it or roll it into shapes that match the ideas you had in the last step. Use the tape to connect pieces of paper and build the tower higher and higher. Be prepared for things to not work quite the way you planned. And remember, if you need to, you can always trade in your paper and tape for a fresh set. Now it's time to test. Take your tower to the testing surface and rest the metal washer on top. Place the fan about as far away as you can from the tower and turn it on. Slowly move the fan closer and closer to the tower until it falls over. Record that distance between the tower and the fan, and you'll know how well you did. If time allows, do it all over again. Think about the results from your first experiment. Did the tower last as long as you wanted it to? What are some design changes you would make? Could you build a better tower with different materials? Or how about fewer materials if you're up for a challenge? And just like that, you have participated in the same design process that engineers use when they design and test skyscrapers. Whenever civil, mechanical, or structural engineers design a structure, such as a tower, they take high winds and other lateral forces into account in order to create as much strength and stability as possible. Wind tunnel testing allows engineers to experiment with different shapes and materials to see how they'll be affected by the kinds of winds that any building will eventually have to endure. Wind tunnel testing allowed engineers to identify a special shape for the Shanghai Tower, which shaved millions off the cost of building materials, especially when compared to other rectangular skyscrapers. This is no small feat either, At over 2,000 feet tall and 128 stories, the Shanghai Tower is constantly exposed to some very powerful wind. Scientists and engineers use computer models and mathematical formulas to predict the effects of wind more accurately than ever before. Before the advent of technology, predicting how wind would affect a structure was very difficult. Now, scientists can analyze these complicated currents and plan for durability and strength in new ways. Other wind-related factors include the building's height, weight, and means of anchorage to the ground. If a building is very tall, scientists have to take into account the amount by which the building will sway and tilt in the wind. People prefer that a building do that as little as possible. So, now that you've had the opportunity to try it out for yourself, I hope you'll keep coming up with new ideas and new solutions. Engineering a strong tower can be a challenge, but there is no end to what you can make when you dream big.